Okay, so we're going to do a problem on relativity, and so the question that we're given is, a law enforcement officer in an intergalactic police car turns flashing light and sees it generate a flash every 1.5 seconds. A person on Earth measures that the time between the flashes is 2.5 seconds. How fast is the police car moving relative to the Earth? So what we want to find is the difference in time that will give us the difference in speed. So the formula for this is the change of time from the perspective of the Earth in this case is equal to the change in time from the perspective of the police car, where the square root of 1 minus the velocity of the object squared over the speed of light squared. So that's the formula that we're going to use. I'm going to erase it so I have room, but you can pause the video and write that down. Alright, so now we're going to actually plug in values. We're going to have 2.5 seconds is equal to 1.5, and it's a ratio, so it doesn't matter if we do minutes or seconds, over the root of 1 minus v squared over c squared, because that's what we're trying to find. So then we're going to try to isolate v as a variable, and so we're going to multiply both sides first of all by this quantity. So then when we do that, we get 2.5 times the root of 1 minus v squared over c squared is equal to 1.5. So then we can divide both sides by 1.5. Sorry, calculator issues. Okay, and when we do that, we get 1.6 repeating this equals 1, and so then we can actually just want to split this divide both sides by 1.6. I'm just going to get 1 over 1.6 for now, and then so we'll square both sides. So then we'll get 1 minus, that velocity squared over speed of light squared for 1.6. And then after this, squared. And so that'll be 1 squared over 1.6 squared. And then after this, we're going to want to add this to both sides to make positive, and then subtract that from both sides. We're going to get squared is equal to v squared over c squared. Okay, and then so what we want to do from here is we're going to multiply both sides by c squared. So then we're going to get c squared times 1 minus 1 over 1.6 squared equals velocity squared. Okay, so going to plug this into a calculator. So the speed of light is the c equals 299,792,458 meters per second. We're going to have c squared, and then we're going to have 1 minus, and then .36 equals v squared, and then so we're going to multiply 1 minus 0.36, then we're going to multiply that by the speed of light. Speed of light squared. It's going to be 0.64 times the speed of light squared. Okay, and then so we're getting 5.7552033,144 times 10 to the 16th is the velocity squared. So then we'll just take the root of that Then we get the velocity. We'll just take the root. Then the velocity is going to be 239,833,966.4 meters per second as seen from the Earth, which it makes sense that it's going as fast because a difference of 1 second is truly massive. So yeah, that's how you would solve that problem.